So the periodic table shows you how the elements are set out. So elements are just groups of atoms of one type of thing. You can just call it a fundamental thing, the smallest sort of group of things you can get. So if you start off with looking at hydrogen, you can see there's a 1 there and a 1 there. This just means there's 1 electron, 1 proton, 1 neutron. So 1 will be the atomic number, 1 will be the molecular number. Okay. So the atomic number is the one we're interested in. And you'll see that it increases as you go across by 1 each time. So if you start off with lithium, it goes 3, 4, 5, 6, 7, 8, 9 across 1 each time as you go across the groups. So this is called a group. Just the number there is the number of electrons in the outer shell. Alright. And the fewer electrons there are in the outer shell, the easier it is for it to react. So that means that this one is going to be more reactive than that. So as you go along, they get less reactive. Well, for metals they get less reactive, but metals are less reactive because to react as ions, or to react as in a covalent bond, you need to lose or share an electron. While these guys, the non-metals, they need to gain an electron. So they will get more reactive as you go closer to this side, and that's because they can easily attract electrons if they have fewer there already. So if you ever have to work out how many electrons there are in each shell, you need to remember that it's the top number that really matters, this number, the proton number, the atomic number. Okay, actually it's not always at the top, but you've got to remember that it's the smaller number. There'll be two numbers, and the smaller number will be the atomic number. And to check it as well, you can check that after you go across one, it goes up each time. So here it's 26, then 27, then 28, and onwards. So this shows you that example again. So it starts with hydrogen this time. Hydrogen has 1 proton, which means it also has 1 electron. Why is that? It's because all atoms are neutral, they're not charged. Helium has 2, and you'll see in the table that it goes hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and then we have neon. So if we look at the groups of these elements, it's 1 for them, 2 for that, 3 for that, 4, 6, 7, 8. So these are the groups of the elements, meaning that's the number of electrons it has in its outer shell. So we can see here, this has 1 in its outer shell. That means it's really highly reactive, because an atom will always want to fill its shells. And that's the whole point. That's how we get compounds in the first place, because every atom wants to fill its outer shells. Now, we can see here, I've got an example of beryllium, because beryllium is Be4. That's its atomic number, meaning it has 4 electrons plus 4 protons. That's just because 4 minus plus 4 plus equals 0. So it's 0 charge. And its electronic structure is 2, 2. Now, the first 3 electron shells are 2, 8, 8. So for beryllium, it'll be trying to get rid of those 2 so that it can go from being 2, 2 to 2, 0, a more stable form. Every atom tries to get to a stable form, which is why we would get beryllium 2 minus usually. Nope, 2 plus usually. And that's because it would have got rid of these 2 electrons. And if you get rid of 2 minuses, then you're left with 2 plus. So, different elements can join with each other, and that's actually more common than the same element joining sometimes, in exams anyway. So for example, sodium chloride. This is a compound because it has a chlorine and a sodium atom joined together. Now, why is there only one of each? That's because chlorine is in the 7th group, so it only has to get one more electron to fill its outer shell, which means this will have the form 2, 8. So 2 electrons in its first shell, 8 electrons in its second shell. While if you have chlorine on its own, it's actually 2, 7, which is unstable because it's missing one electron. Sodium becomes sodium plus ions, and it's a plus because it's lost that electron. So the electron's gone to the chlorine, the chloride ion. So that's an example there of ionic bonding, and it all is to do with the outer electron shell. Now, hydrogen, it doesn't actually form these, so it doesn't form H+, it doesn't form Cl-, because nothing happens. The electrons don't transfer, they just get shared, and that is covalent bonding. And you just have to remember which ones do covalent bonding and which ones actually do ionic bonding. Alright, so this is another compound. It's a compound because it has carbon and oxygen. Okay, so that's 2 different elements. This is a molecule because it only has oxygen. It has 2 oxygens, which means that that is a molecule. It's not an atom because an atom would only have 1 oxygen. Okay, so also it's important to know that when atoms of different elements combine, they form different characteristics. So, for example, if we look at the state of these atoms, we look at oxygen, it's a gas when it forms a molecule. We look at carbon, it's a solid when it forms molecules. But then if they join together, you get CO2, which is carbon dioxide, and that's obviously a gas. Which means the state has changed.